We are going to work on the Leetcode problem 3106. So in this problem, you'll be given an input string s and an integer k. And you need to write a function that generates the smallest string that can be generated from this given input, also with a constraint k. So it's a little bit confusing to understand, but they have given us a few examples to make it easier. So here's an example where they have given us an input string and k is equal to 3. And they've also mentioned that all the characters from A to Z are placed in a cyclic order. So what they mean by that is if you want to convert the character Z to the character A, it takes only one spin. So here's an example. So in order to convert this into A, they just have one change is required. Similar from B to A, one is required. From B to A, one is required. And after that, since they have given us a constraint that k is equal to 3, so that's the number of times we can modify each character in the string. The output or the smallest string that can be generated is AAAZ. So this way the distance between them is equal to 3. Here's another example, k is equal to 4. So for the given character x, to convert it to a, 3 spins are required. So x, y, z and then a. Then the second is already a, so nothing is required. And then they have x as input. So here we have already used 3 characters, from the constraint, and we can just update one more. So we cannot bring it back to A. So what they do is they just reduce it by 1, so W. So this is the output string that can be generated. So yeah, I think it's a straightforward problem, and the way we are going to solve it is we are going to traverse the string, retrieve each character in the string, and based on the constraint, what's the smallest character that can be generated from it. And then we keep appending it to the string until we have traversed the entire string or until the constraint k is 0. So yeah, first let's try building a string builder. So if you're familiar with this, this is actually the easiest way to append characters to the string, and it has a method append which we are going to use. Then we're going to create a for loop to traverse all the characters inside the string. So for int so they've already given us a constraint that the letter k represents the number of times we can actually modify each character in the string. So if k is equal to 0, there's nothing to do. Before that, I'll retrieve the first character. So character ch is equal to so we are retrieving the character at each index point. So if k is equal to 0, we don't have much to do. We just say sb dot append. Else, now we have to do the processing. So they're given us that the characters are in a cyclic order. So converting it from Z to A just takes 1 point. And same thing from B to A just requires 1 point. So we need to see which is the easiest way to convert this character into A. Is it to move it forward or move it backward? So for that, we'll create this variable. So what it does, it stores the minimum value for converting it into a character A. So one way to do that is using the function mat.min, and can say that the character ch minus a. So this is if we move backwards. So for example, from B to A, we just need to move it 1. So we can say that that's one way. The other way is that if we have given a character y, we need to move it 2 characters front to bring it back to A. So for that, we say z minus ch and plus 1 because we need to take it back to A. So this will give us the value required to bring it to A. We have a constraint, right? So we need to make sure that the value is within this constraint. If it is, we just say sp.append ch and k is equal to k minus val. So we are just updating the number of points remaining. However, if it's not, then the way we are doing it here, where we moved x 1 time in the back to make it w, we need to do that. So for that, we'll say ch equal to, and we have the input, and it's subtracted by k. So what it'll do, it'll move it on the number of characters back that we need. And then we say k is equal to 0. And append it to the string builder object. So yeah, we keep doing it until we traverse all of the characters in the string, and the end we return sp. So yeah, just to recap, we create a string builder object, we create a for loop to traverse the entire length of the string, we retrieve each character, and then we check against the constraint. If it is 0, there's nothing to do, we just keep adding the character to the string builder object. Else we find out what is the easiest way we have to convert it to the minimum character. We don't see, we're converting it to here, and we are subtracting it. Else, we just go back as much back as we can, and we add it to the string builder. So yeah, let's try running it. So 3 use cases have passed. We'll try submitting it. So the time complexity for this is O of n, where n is the length of the string. Same thing for space complexity, we are using a string builder object. So that also be O of n, where n is the length of the string.